Okay, now welcome back, hopefully. Again, the stream crashed, but it was not me clicking on this build icon, but it was actually happening when I was including this frontend full system.h. It seems like some pre-compiler tool will then analyze this file, and then the operating system will hang for a while, and this will lead to the encoder timeout, and this will lead to this stream crash. But I have checked several things in the meantime. So I have built the file, so I can now click this build again, and you will see that there's no work to do, and the build was finished with the exit code 0. We are having a debug build here, which means that the program will run slower than with the release build, but we will have the opportunity or the possibility to step through the code using the debugger. So without further ado, let's try to run this code. So I click on this launch configuration here, and I say, yes, I want to use that. And I get this error, which I got before, which I don't know why this is happening. I just clicked several times on this launch, and then it somehow worked, but it is not at the moment. So let's just open this launch JSON. Let's see if there's something here which we can change. But I do not think that something is wrong here. So let me just quickly run that again. And now magically there's no error message anymore, and it seems to start the debugger. Yes, the debugger is now stuck in the beginning of this main function here, and I will just continue it. It is loading the vocabulary as usual, and it is opening this pangolin window in which we will at some point see our images and our 3D trajectory. So this is running, and hopefully we will have some results visible here in a minute. Let's make this window smaller. And as I said, this is a debug build. That means that things are very slow. And yeah, I'm not sure what we will do about that. I think I will not let the algorithm run for the whole video sequence, but just let's see if we can see some like some initial estimates of the trajectory and the 3D map, and then we can maybe jump into a specific part of the code and see if we can debug it. So this is a test run to see if we can work with this kind of development environment, and if we are able to change specific code regions to our liking. Okay, so nothing is happening, it seems, but in the background, the images are loaded. And once the images are loaded, this user interface will change and will show the first estimations. And now you can see that now something is happening. Visually, something is happening. We have a very low tracking frames per second rate, which is about 1. So we have 1 frame per second. We have 3000 frames in total, so this will take 3000 seconds, which is almost, I think, an hour. I think it's an hour. No, it's probably even more. So that's why I think we will not sit here and let the whole sequence run. But if the tracking frames per second, if this will get faster, then we might be able to see the whole trajectory. But it is actually getting slower. So yeah. But other than that, I think the camera estimation looks quite good at the moment. The point cloud too. I mean, that's not a big surprise because it is basically the unmodified, well, besides some little tweaks, but it is actually the unmodified original source code. So I would expect the code to work on the standard dataset, like this TOM mono benchmark dataset that is used here. But it's always interesting to see what the algorithm is estimating given those images. So we have some graphics drawn here in the 3D viewport. I will quickly go over that. So we have our point cloud here. We can zoom in and we can see that the individual points that are rendered here, they are just point primitives, but you will see that they are not just like one point, but you can, if you really like squint your eyes, you will see that it is possible to see this residual pattern in some places. So there is the central point and there are other points outside, like around this point, scattered around this point. Let's quickly make this more concrete and let's go to the settings.header file, I think. Okay, let's go to the CC file rather. And here you can see that here the static pattern is defined using 10 different kinds of patterns. And there's, for example, pattern 1, which is just this central point and no neighboring pixels. But the one that we are actually using, I think pattern number 8 or 9, no, number 9. So in the DSO, in the direct sparse odometry algorithm, this pattern is being used. So we have the central pixel and then we have this rotated open square. So we have, in total, we have 3 plus 3 is 6 plus 2 is 8. So we have those 8 pixels that are used to generate the 3D points. So if we go back to this user interface, you will see that we do not have just simple points in 3D space, but we have those, those kind of clouds or blobs that are being generated in 3D space. Next we have this red camera symbol, which is changing, and this is the current camera view. So this is aligned to show the bottom, like the floor here. And then we have those blue cameras, which will change depending on where we are with the camera. And I think there should be 7 of those blue camera symbols here, because they reassemble our sliding window. So currently we have those 4 camera symbols here, and we have, okay, maybe it's even 8 poses, with the current camera being the 9th. And they will pop in and out depending on how the camera is moving. Now this blue camera, for example, it just vanished. This is because depending on how the camera is moving, we want to keep a different kind of number of keyframes in our sliding window. So as long as the camera is not moving a lot, but rather just translating a little bit and rotating a little bit, all those keyframes will be very close to each other. But once the camera starts moving more rapidly and more like faster, then those keyframes will then be a little bit more apart. Okay, so we have those the red camera and those blue cameras here. And we also have this red trajectory that shows the path that we have. I think we can also disable this. So with this user interface checkbox, we can disable the trajectory display. We can also disable the current cam, so the red one. And we can also disable the keyframe cameras from the sliding window. And we should be able to show the full trajectory, but this is somehow not working. I noticed that some of those checkboxes are not really working. For example, the depth, I don't know, the depth is not displayed here. 3D is displayed, of course. Video is also displayed, but the residuals, the frames window, and so on and so forth, these are not showing up. But this could also be a setting that we need to set in the, or an argument that we need to pass. So this might be a user issue that I have not set those arguments. But now you can see that the camera is moving sidewards. And therefore the sliding window is then also adjusted during this movement of the camera. And it usually tries to keep some frames from the beginning. And you can see how it is updating the keyframes that are close to the current camera. So that if the current camera is moving rapidly or something is happening to the camera, like a shaky camera, for example, then the other keyframes might be able to help with estimating the camera pose, because they might have seen features in the images that the shaky camera is not seeing anymore, or which are blurry or something like that. But at some point, those blue cameras from the beginning, they will disappear, but they are still stored in the 3D viewer, of course, but also in this global keyframe map. They are just not used anymore in the sliding window, so they are marginalized. They fall out of this sliding window, like here once again. And you can see that the details are very good when we are close to the camera, like for example this floor. This is mapped quite detailed, but the other objects that are further away, those are more blurry or more uncertain. They are simply bigger. And they are usually also more erroneous until they at some point are not mapped anymore. Now the camera is rotating around its own axis as well. So it's a freely moving camera in 3D space. Which makes the whole algorithm, I would say, less robust, as there is a high degree of freedom of the camera that needs to be estimated correctly. But it's nice that even by typing out the code, and of course there have been some issues with the specific lines of code that I have typed myself, it still works. But of course there is also a lot code that was copied from the original code base. So this is not like a big surprise now that it works, but it looks very good. And what I did not explain yet is that we have those yellow lines that connect the individual points in time with each other. And those yellow lines, they are visualizing our pose graph. So we have the whole trajectory, which contains many of those cameras, which are not visualized here. And those are linked with each other. So we know that from one point in time to the next point in time, we are moving with a specific transformation, like with velocity and an angular rate. And this is shown with those connections here. And we can change the display to whatever we like. We can change the colors, we can change the way this is displayed. Maybe we do not want to use lines here, but we want to use points, for example. Then we can change that. And you can see that some of the points that are displayed here, they are clearly outliers. So if I deactivate the camera and the trajectory, you can see that here in this white space there are some points which shouldn't be there. So what we could also do is we could, when these points are drawn, we could check if they are, for example, if they have a specific state. For example, when we take a look at the what was it? I think the feature. no, the point probably. With the point.header file, you can see that the point does have a status. It can be active, it can be an outlier, it can be outside of the boundary, and it can be marginalized. And we can use this information for every single point that we have to color code them, for example, in 3D space. So currently every point looks, yeah, the whole map at the moment, the whole map looks like a ghost town or something, like really scary due to the grayscale colors. But we can, yeah, colorize the point cloud given specific data. What's often also being done is the points are colored depending on the vertical axis. Oh, and I noticed one thing that is obviously missing when we are looking at the current cam, for example. We do not know the coordinate system of this camera, so this will also be a nice addition we can add here. Ghost town, haha, yeah, yeah. Yeah, it reminds me of a really like a scary place, like some Silent Hill, I don't know, place or something. Yeah, so there are many things we can change with the code. I would like to have this completed and then take a look at the point cloud individually using Blender, for example. But I'm afraid that this will take some time, so I will probably do that off stream. And I think it's now time to define what we want to modify in this code. If we want to modify something, or if we want to analyze specific behaviors, maybe use our own data set that we can also create together. Yeah, I'm open for ideas here, so feel free to post something either in Twitch or later in the YouTube recording. If you have specific ideas, we can then explore those ideas together. Okay, but I have to say that I'm quite happy that this thing is now running in the state that the original code base provides. And at this point, I'm willing to end the stream and to say that we will, meet up the next time with the next live stream part. I will take a look how I can optimize my environment, because currently it is a bit annoying that it takes so much time to let this LDSO run. So depending on what we will continue with, so if we continue with exploring multiple data sets, for example, it would be a better idea to not create a debug build, but a release build, and then just quickly check different data sets until we find something interesting happening. Whereas if we rather will analyze the algorithm, then we will have to keep the debug build, but maybe get a different data set that will not take as long as this one. So not a data set with 3000 images, but maybe a data set with 10 images, or, well, 10 I think is the minimum. It's maybe, say, like 50 images or something, so that we can handle it on stream. Yeah. I think I need to decide here. But what I definitely want to do is I want to add the display of a grid in the 3D viewer, and I also want to add the display of the coordinate systems for the current camera and for the world coordinate system as well. Okay, so to give you an outlook for what we will take a look at the next time, this algorithm will hopefully, if everything is coded correctly, it will create 3 important files. It will create a results.txt file. Let me check if I can show you that. So we have the main file here, and at the end somewhere we'll have this output file, and this will be, I think, a text file. So a results.txt file. Let's look up where this is defined. So this is defined in the beginning of this main file. The output file is the results.txt file, and it will be created in the parent directory of the current program. And this is one file, and there will be a results.txt.noloop file as well. And let me quickly check if this is already created somewhere. But I do not see it here. Okay, so this, yeah, sure, it is not created yet because we did not have the full system before. And this is part of the full system, so we cannot have it at the moment. But hopefully once this, like this main thread here is finished, those files will be created. And lastly, there will also be this pointcloud.ply file. And the next thing I will do is probably take a look into how those files are structured and how we can visualize them. I think I will load them using a custom script inside of Blender to visualize the point cloud and the trajectory in the same coordinate system, in the same file. And I think I will also create a screenshot from that and put it on the GitHub repository so that this GitHub page will look a little bit more interesting. And then over the course of multiple streams, I think we might be able to add several things to the LDSO and analyze things. And yeah, all depending on what you will suggest and what I come up with as ideas. So stay tuned. Thanks for watching. And with this, I hope I can see you next time, and I wish you a great day. So see you until then. Goodbye.